Otherwise referred to as randomized block designs, randomized block experiments can be used to collect specific data on a specimen that might otherwise have several variables. Initially, we can take a multi-factor data set or scenario that seems to be difficult to analyze and break it down further. We do this by blocking the data set into small subsets based on factors such as age, race, processing speed, color, all depending on what you are analyzing. We can then continue to break each subset down continuously into smaller blocks until we are comfortable to analyze. Now, once we have the dataset divided up into the subsets we want, we are ready to analyze those results to compare them. In the end, this method of randomized block design allows us to take complex scenarios with multiple parts and simply analyze them without completely randomizing the results and getting inaccurate readings. Now, before we hop into an engineering-related application for randomized block design, this is an example of a hypothetical randomized block experiment done to find a cure for COVID-19. The company here is looking to test 200,000 individuals with two possible vaccines that might cure patients. If the company were to randomly divide the sample set into two equal groups of 100,000 people, there would be countless variables swaying the statistics one way or another. Therefore, we use a randomized block design. The company first makes sure to divide the sample into an even 100,000 women and 100,000 men, and then divides those subsamples into four equal groups of 50,000. It is important to note that the company could add in other subsets for different underlying conditions the individual might have, or the individual's ethnicity to find more details about their experiment. This is the beauty about randomized block design. They can be fully tailored to your liking. Now for a more industry-related application. Say you are working as a software engineer for Intel on the new i9 processor in their latest laptop, and you have been running into some issues with the computer having a tendency to slow down as the storage space is filled up. You would want to analyze the computer speed of each computer with each processor at different levels of storage space used. By taking a sample of 90 laptops and dividing them into three groups based on their storage space, you are able to have a controlled and unbiased experiment to determine which processor might help in developing the new i9 processor. Each set of 30 laptops is divided once more into three subsets each, and each subset of 10 is then given a different Intel processor. Now, instead of just taking a 90 laptop sample and dividing them into three sets of 30, you have now narrowed down the different factors to have 9 sets of 10, and are then able to finally compare the results and conclude which processor technology performs best under each storage percentage.